We've been talking about different concentration units, and right now we're going to talk about mole fraction and mole percent. So mole fraction is given the symbol chi. So chi for the solute is going to be the moles of the solute divided by the total number of moles. And that's the solute and the solvent. So you could look at it this way, or with variables, you could look at it that way. The mole percent is just taking the mole fraction and multiplying by 100. So this example gives us some practice in calculating various concentration units. And most concentration calculations do end up being largely dimensional analysis plus then understanding the definition of the unit, the concentration unit. So a solution is prepared by dissolving 50.4 grams of sucrose in 0.332 kilograms of water. The final volume of the solution is 355 milliliters. Calculate the concentration in these units. So we'll just do them in order. So to calculate the molarity, we need to know what does molarity mean? Or what are the units of molarity? Moles per liter. So this is going to be the moles divided by the liters, and it's the moles of the solute. In this case, it's sucrose. I'm going to call her Su, divided by liters of solution. Okay, so did they give us moles of sucrose? No, they did not. They gave us grams, but we can do that conversion. So 50.4 grams of sucrose, and then I'm going to put my conversion factor here. I want to multiply by moles and divide by grams, and then the grams are going to cancel out. And I need the molar mass of sucrose, so I'm going to calculate that quickly. We have 12 carbons times 12.01 plus 22 hydrogens times 1.008 plus 11 oxygens times 16. So 342.3. So 50.4 divided by 342.3. So that's going to give me 0.14724 moles of sucrose. So that is the value for the numerator here, 0.14724 moles of sucrose, divided by the volume in liters. Well, they didn't give us the volume in liters, but they gave us the volume in milliliters. 355 milliliters is equal to 355 times 10 to the minus 3 liters. And if you put that in regular decimal notation, you get 0.355 liters. So we'll divide by the volume in liters, 0.355 liters. And I'm going to get 0.41476 moles per liter, which would round to 0.415. And another way we can indicate those units is with the capital M. So the molarity is 0.415 moles per liter. This should be kind of old hat because we've been doing things like this. Okay, let's find the mole fraction. What does mole fraction mean? It'll be the moles of the thing we're interested in. So typically that's the solute. So moles of sucrose, and what do we divide by?
Moles of
It's the part over the whole.
yeah.
So we need
Solution.
the moles of the whole solution, right? So there's two parts, the solute and the solvent. And so down here, we're going to have the moles of sucrose again, plus the moles of water. Well, we already know the moles of sucrose, so that's nice. 0.14724 moles. And then in the denominator, that number comes in again, 0.14724, plus we need the moles of water, right? So we're given a mass of the water. So we have 0.332 kilograms, and we want to get to moles. Well, grams to moles, we can take this kilo and replace it with what kilo stands for, which is 10 to the positive 3 grams. And then we want to multiply by moles, divide by grams. We need the molar mass of water, 18.02. So 0.332 times 10 to the third divided by 18.02. And we're going to get 18.424 moles. So that number is going to come down here, 18.424, and the unit down there will be moles as well. The mole units are going to cancel out. Mole fraction, mass fraction, these are not going to have units. Be a little careful on your calculator. 0.14724 divided by, I'm going to use parentheses, 0.14724 plus 18.424, close the parentheses, and I get 0.0079284. And so rounding that would be 0.00793 is the mole fraction of sucrose in the solution. Any questions? The train is a question. I'm moving. We're just doing tally marks. Forget the time, too much brain power. We're just going to count trains instead. I think it'll be less disruptive, but still entertaining. Okay. Molality. Molality and molarity are spelled the same except for this one letter. So if you see molality on an assignment, don't think it's a typo. Okay? I don't make typos like that. Make other typos, but not ones like this. So molality, what's molality? Remember?
Moles per kilogram.
Yeah, it's moles of solute. So moles of the sucrose per kilogram of the solution or of the solvent?
Solvent.
It's of the solvent. Per kilogram.
How would you know the kilograms of the solvent typically?
That's a good question.
I mean, isn't it all?
So if you want to know the molality of a solution, then you're going to weigh the solvent before you put the solute in there. Yeah. Or you could measure the volume of the pure solvent and then convert to mass using
What if
the
you have,
density.
like, an unknown sample, you just want to know the molality, you have no way to know. Like, you have an unknown, you have a solution and you want to know the molality of it.
Well, if you had an unknown solution, you wouldn't be able to just tell the molarity either,
Okay.
right? You'd have to test it somehow. So, yeah.
There'd be no way of knowing.
Well, I mean, you just have to test it, and it's going to be maybe a little trickier than molarity, but it can be done.
And why kilograms? Why not grams?
Well, that's an excellent question. So, molarity is moles per liter of solution. This is moles per kilogram of solvent. How much does 1 liter of water weigh?
Oh,
A liter is 1,000 milliliters. It weighs 1,000 grams,
grams per.
a kilogram. Okay, so this is not exactly the same as the mass of the solution, but it's really
This
close.
is the density.
Yeah, because the density of water being 1, so it's going to be really close. And we use kilograms here because molality is a concentration unit that's not going to change with temperature. Okay, so we calculated the moles. So we've got those already. 14724 moles of sucrose divided by, oh, look at that, they gave us the mass of water. So if they're asking you to calculate molality, they're going to have to give you all the pieces of information that you need. So 0.14724, yeah, I typed that in wrong, 14724, divided by 0.332. So 0.44349 moles per kilogram. And if we round that to the correct number of significant figures, we get 0.443. And the other way we can indicate that unit is with an italicized M. So the molality is 0.443, the molarity is 0.415. They are similar in size, right? And there's very few places that you need molality, but one of those places is colligative properties, and that's what we're talking about today. Okay, mole percent. How do you calculate mole percent?
Mole fraction.
Is the mole fraction times 100. So, we've used percent a lot, and percent is used a lot in everyday life, right? And so percent is the part divided by the whole thing, and that can be number of people, it could be mass of elements, it could be lots and lots of different things, right? But the part that you're interested in divided by the whole thing, and then to make it a percent, we multiply by 100. So this is equivalent to the fraction, the mole fraction, right? And then you multiply by 100 to get the percent. So mole percent is mole fraction times 100. So that's going to be 0.00793 times 100, which will be 0.793%. Now, in terms of significant figures, the 100 here, that's part of an equation. It's an integer that's part of an equation, and that's an exact number. So however many sig figs your mole fraction has, that's how many sig figs the percent's going to have. Okay, percent by mass. Well, mole percent was the mole of one part divided by the moles of the whole thing. So percent by mass is the mass of the solute, so the mass of sucrose, divided by the mass of the solution. Now, a lot of times in these problems, they don't give you the mass of the solution, but they did give us the mass of water and the mass of sucrose, and the mass of the solution must be the sum of those. And it's percent, so we multiply by 100. So grams of sucrose was just given to us, 50.4 grams. And then down here, we've got 50.4 grams plus 0.332 kilograms of water, right? So that's going to be 332 grams of water times 100, 50.4 divided by the quantity, 50.4 plus 332 times 100, 13.1799. %. There will probably be a percent by mass question on exam 4. A common mistake that students make is they take the mass of the solute and divide by the mass of the solvent. And I am warning you, I will try to trick you into doing that. I'll give you a problem like this where I give you the mass of the solute and the mass of the solvent. I don't give you the mass of the whole solution. I'm going to ask you to calculate the percent by mass. And making that common mistake will be one of the multiple choice answers, right? So watch out for that. Any questions?
I don't know if you can talk this next to the why mass of solvent, not mass of the solution?
Well, it is. Why would I give you mass of solvent?
No, I'm saying the molality. Sorry, I just didn't.
Oh, that's a really good question. And about the only thing I can think of is that if you had a fairly concentrated solution, then the mass of the solution would be significantly larger than the mass of just the water. And so then that would cause the molality to be significantly different than the molarity.
Okay.
So by using the mass of the solvent, those numbers stay closer to each other.
Oh, okay.
That's the only thing I can come up with right now.
Okay.
Good question.
And they have to be similar? Or, I mean, like,
Well, it's not that they have to be similar. No.
does it make it makes it easier though to make it easier to calculate or sorry.
No, don't be sorry. Honestly, I don't know. There's got to be some historical reason that they're using mass of solvent instead of mass of solution.
Because it's just weird to me because like one is like I don't know, I thought like I mean it seems like it's just like you have molarity which is mass or amount of solute over
Divided by the whole
solution.
volume of the thing,
You would think it would be like
the whole mass.
what do you call it, like comparable, like it would be like
Yeah.
if they're related they would be like I don't know.
Yeah. I never thought about that, but that's an excellent question, and I don't know the answer to that one. Okay, let's practice converting between concentration units. One of your titration experiments where you calculated the mass percent of vinegar, in the post-lab questions it made you convert that into different units. And so that's kind of what we're doing here. What is the molarity of a 10.5% by mass glucose solution? The density of the solution is 1.03 grams per milliliter.
It's ridiculous.
That's ridiculous.
I think they've heard it by now.
Like, we know you're here.
You just really wonder what's going on in that guy's life right now. That he's just, is he just in a silly mood, or is he angry about something?
Power trip. Does it 'cause he can't.
Right.
The train comes through Reedley, not very often, not even once a day, and a lot of times it's like 3 a.m. But sometimes it's in the evening, and people had complained about
How many
the
times they honk?
honking of the horn, because they have to sound the horn for each intersection.
There's
So
no-
this guy right here, like, there's the one intersection, right? They're just going overboard. But in Reedley, there's a bunch of intersections. But so for quite a while after that, they honked the horn way more than they used to.
Because y'all complain.
Just like,
Complain.
it's like in your face. So I've got this, imaginary relationship with these trains.
They have to do it for every intersection or just?
My understanding is they have to do it at every intersection.
Okay.
Yeah. Okay. So here we're given a concentration and we're asked for a different concentration. And so this really is just conversion of units. Well, let's write down what we've got. We've got 10.5% glucose, and I'm going to call it glue. What does 10.5% mean? 10.5 per 100, right? That's literally per cent. Cent refers to 100, right? 10.5 per 100. Well, this is a percent by mass, and so we need to use mass units here. You can use any mass unit you want as long as you use the same one for both of these. And so it's 10.5 grams of the glucose per 100 grams of solution. And then the other thing they're giving us is the density, 1.03 grams per milliliter. And here they're a little clearer, and they're saying the density of the solution. So this is grams of solution for every milliliter of solution. Okay, so we wrote down what they gave us. Now let's write down what they're asking us for. They want the molarity. So molarity is going to be moles of glucose divided by liters of solution. If you could write that as capital M, but you're going to make yourself crazy doing that. This is one of those unusual circumstances where we don't pick our starting value by which one does not have per in the units. Both of these have per in the units, and our answer has per in the units. We're trying to find a concentration in molarity, so what we need to start with is the concentration in mass percent. So we want to convert grams of glucose per 100 grams of solution into moles of glucose per liter of solution. I think most students would agree with the statement, fractions are not my friends, right? Because I love this t-shirt. 4 out of 3 people don't understand fractions,
That's a fraction.
right? Yeah, let that sink in for a minute. So let's kind of separate the numerator and the denominator here. I'm just going to continue this line, and we're just going to look at the top, converting the unit on the top, and separately converting the unit on the bottom. Can we convert grams of glucose to moles of glucose?
Yes.
Yes, we can. We just need the molar mass. They gave us the formula, easy peasy. Grams of solution to liters of solution. Well, why did they give us this density? We're supposed to use it, right? We can go from grams to milliliters using the density, and then we can go from milliliters to liters because we understand metric units. So I'm going to do the top one first. 10.5 grams of glue times in a line. So I want moles on top and grams on the bottom. A lot of you guys are still just writing numbers down and not including the units, and sometimes it works and sometimes it doesn't. It really goes better if you have the units in there. So we need the molar mass of glucose, 12.01 times 6 plus 1.008 times 12 plus 16 times 6, 180.2. So 10.5 divided by 180.2. 0.582, and the next two digits 69, and that's moles of glucose. So this part, the numerator, we converted right here. Now let's do the denominator. We're starting with 100 grams of solution. And we want to convert that to milliliters and then to liters. So I need grams to come down here so they cancel out. I need milliliters down here so they cancel out. The density relates grams and milliliters. 1.03 grams. Grams is in the denominator, so that's where the number goes. Here I have milli in the bottom. I'm going to put what it means on the top. And I should be good to go here. So 100 divided by 1.03 times 1 e negative 3. 0.097087 liters. So the denominator calculation I did down here. The molarity is the moles of glucose divided by the liters of solution. Here's my moles of glucose, there's my liters of solution. So 0.058269 moles divided by 0.097087 liters. .60017 moles per liter, 0.600 molar. So 0.600 molar solution. Any questions?